name is Philipp Langhans. I work for the Ethereum Foundation on... Should I use the microphone for the recording? Okay. Hello everyone, my name is Philipp Langhans. I work for the Ethereum Foundation on the JavaScript team. And I'm going to talk about ETH package, Ethereum flavored packages today. So what are packages? Packages, sometimes also called archive files, container files, usually have the extension zip, tar, they can be gzip, ASAR, jar files, APK files, Android applications. All of these are packages. And when I did the slides, I thought, okay, that sounds like a really dry topic, and I tried to spice it up a little bit, and I hope it worked. So why are packages so cool? You can put different things in them. So they're very versatile. You can put images in them, binary files, metadata files, source code, everything you can think of. And that makes them really easy to share and to transport things. You end up with one download link, you can attach it to an email, and it makes everything much easier if it's contained in a package. It also becomes easier to do management of these packages because you end up with this kind of snapshot. So a certain state of, for example, your software project can be captured by one package, and then you can do version management and dependency resolution and all of this. You can encrypt them if they contain valuable information, and they can be signed. And this is the most important part. And because they are so cool, there's already a bunch of formats for packages. So are Ethereum flavored packages format 1001? No. We only focus on the signing aspect. You can take whatever package format you want to use and make it an Ethereum flavored package. So this is only relevant for signed packages. But before I jump into the solution, I want to really stress why it's an important problem to solve. And to understand this, we should first look at traditional file signing, not package signing, but only like one file. And we will use Monero as an example. I hope no one from Monero is here, or maybe they are. Okay, so you want to avoid this basically. You want to sign your stuff because you don't want someone else to replace your binaries and then have your users hacked, for example. This is what we don't want, and this is why we use signed packages, for example, or signed binaries. So how does it work? What do we have to do? The first step is we take our binaries and we calculate the hash, and then we have binaries and we have hashes. And then we can publish our binaries, so we upload them to our web server, make a nice user interface for everyone to download, and then we do the same for our hashes. We upload them to our server, we have these nice hashes for all the binaries. Okay, step 2. We create a lot of instructions and warnings. So on the left, this is actually a screenshot of the instructions, what you should do with these binaries after you downloaded them. So first you install more software, and then you import signing keys and verify hashes, and you verify binaries. And then also warnings are important. Strongly advised to verify. Always verify your downloads. So what is the problem with this? Okay, so the first problem is you upload the binaries and the hashes probably to the same server. And if an attacker gets access to your server, they get also access to the hashes. So what is keeping them from just computing new hashes and replacing your hashes with the new one of the modified binaries? The other problem, or they don't do it. This is actually why it was discovered. So it was sitting there, the modified binaries were sitting there for quite some time, but the attackers forgot to change the hashes. And then I don't know how many weeks after, someone did it actually, and he was like, this is not what I downloaded, and then it got uncovered. Yeah, that's funny. Okay, the second problem is exactly this. No one does the checking of the binaries. No one is following these instructions. It's way too complicated. So we end up in this situation where you should do something, but most of the time it's meaningless, and then suddenly it becomes super important. So it's a really bad situation, and this makes security really hard, not only for for the users of the software, but also for the developers to get it right. It's a really hard problem, and I don't want to blame Monero. There's like many more projects, teams, people that are doing this. Okay, so one of the solutions could be we take our binaries, and maybe the attacker has access to the server, but then we upload the hashes to a different server. And then the problem is solved, right? But we still have the issue that now the user has to look up hashes, so the user has to download hashes binaries from one address now, and then they have to go to a different address and download the hashes and then go through all the steps. And of course, maybe there's a typo, maybe they're not going to hashes.com, but hashes.org or whatever, and this is attacker-controlled server, and there's many more scenarios where this goes wrong. So this is not a good solution. Okay, so we can sign the hashes. This way, it doesn't matter where they are uploaded, because in the end, we can always just verify the signature of these hashes, and then we know, okay, it was not modified. The problem here is, in order to verify the signature, which is on the bottom here, and this is actually what Monero is doing now. They're signing the hashes. This is the actual screenshot. Okay, now the steps are like the following. To verify the binaries, you go to the GitHub server, you download the key, and then you verify the key with a fingerprint that is coming from yet another server. And then you get the hash file, you verify the hash file, you get the Monero binary, you calculate the Monero binary hash using the same algorithm that they used, you compare the hashes with the signed hash, and then you profit. And still not solving the situation that potentially no one will do this. Okay, now let's talk about package signing. What is different here? If we talk about signed packages, everything is contained in this archive format. So you have all the files that you want to sign inside the package, and then you calculate the hashes, you sign the hashes, and then you place 2 more entries into the package, and you have a signed package. And of course, if you calculate the signature and the hashes, you cannot do this for your signature and hashes that you placed there. And this is a problem again. Because now, if someone wants to receive the package, which is signed, and we have a man in the middle, but the person could also have access to the server, then they can just take these files and replace, for example, the signature with their own signature. And instead of Fluffy Pony is the name from the Monero team, it could be Fluffy Pony, and no one would notice. And this brings us to certificate authorities. So how do we solve the problem of who created the signature? And we already have solutions for this, and they are based on mostly digital certificates and certificate authority. A digital certificate only binds an identity to a public key, so that we know, okay, the person who signed this package also is this person in real life. And the certificate authority is just an entity that issues these digital certificates. So how does it look like at the moment if you want to go through this process? Okay, let's assume we have Alice. Alice has a public and a private key, and she wants to make sure that everyone knows that the public key the private key that is used for signing can be verified and can be traced back to her identity. So she will contact a certificate authority, and she will say, hey, I'm Alice, I own this public key, and she will probably sign this message with the private key. And then the certificate authority says, we need your personal information, Alice. And then Alice gives the certificate authority all her personal information that she wants to bind to the key. And then the certificate authority does some verification, and the verification can look like this. They will call based on the information that she provided. Are you Alice? Yes. Okay, so we're done here, and then the certificate authority will say, thanks for using our service. This is $1,600 please. This is not even unrealistic, by the way. And then Alice will give them the money, and then the certificate authority will say per year. So Alice gives them more money. And then she has a certificate finally. And now she can prove that this key belongs to her and everyone is happy or not. So she doesn't actually get a document, but she gets this little hardware device usually where the certificate is stored. And she will use this device for signing now. Okay, and this, especially from a developer perspective, if you want to guarantee that your binaries are safe or your users are safe, this sounds like a lot of fun, right? Everyone wants to implement this after they finished, I don't know, sprint 120 and they finally shipped. They want to go through this process. Okay, and this is the problem. And Vitalik gave a really nice speech during DEF CON about crypto economics. And the situation is pretty much this. All of this, all these tools and everything, it works, right? The problem is not that the cryptography and everything does not work. We don't need to reinvent the wheel because this stuff is not working. But it sucks. The problem is no one is using it or they're not using it correctly. Okay, so how can we use Ethereum to change the situation? Because the current situation is that people are incentivized against a secure system. They're incentivized against making easy solutions for people to verify binaries, for example. It's way too hard. Learning curve is way too steep. There are no tools. Developers expose themselves to risks by oversharing personal information. Why should everyone know my phone number or address just because I wanted to sign a binary? Especially in times where developers might get arrested for working on cryptocurrency stuff. They have to pay for this additional security, and no one will say thank you, pretty much, for this. And this means setting up infrastructure to store these hardware devices, setting up roles within the organization, and all of this, paying consultants. And this work is often useless, because in the end, if no one verifies the binaries, then why did they do this? Okay, so the idea. We use Ethereum to sign packages. Let's have a look at how these two things compare. Okay, traditional signing, you buy this little hardware device for signing. And in Ethereum, you already have tools that manage your keys. So you might have a ledger, you maybe have MetaMask, and that's already good tools that are widely available for you that you can use, that are secure, they can store your keys, they are easy to use, they have a lot of advantages over buying one of these like new things and setting up new software on your computer that you don't understand. And the second step for code signing, after you sign it, you need to verify it. And with traditional signatures, you get the authentication, integrity, non-repudiation properties, and you get the same. So this, when you use your private key that you use to sign Ethereum transactions, to sign a package, it's the exact same thing pretty much on this end. For the verification, you get exactly the same properties. And you're using cryptography that is proven because we're using it for a financial system that is pretty good at being unhackable. Okay, and this is interesting. Now we come to the authentication step, where you actually verify, okay, what is the identity behind this key? And in traditional code signing, you will receive all the personal information from the developer. And for Ethereum signed packages, you will receive an address. And that's pretty cool because now you can define how much information you're sharing. So you can use one of these identity contracts or identity systems and just enter relevant information like, this is my GitHub handle. Or you can use ENS, and then it resolves to such a name. And everyone that downloads a package and verifies it will see, oh, this package is coming from the person that I expect it to come from. And it cannot be modified in transit. It cannot be hacked in between it. It cannot be hacked on the server. And that's a real solution. And it gets even better because you can use this to incentivize a secure system. So you can completely flip the existing system where people are incentivized to not make it secure because they're just spending on it and it's useless. And now people can actually be paid for it because if you verify it and you see the address that signed it, you can send the address money. And this is cool because you can, for example, create rules into your software that says if dependencies are not signed, please don't execute them. And you can incentivize this with a new license model, for example, where you say, oh, this is Alice, and now she has all the money, she saves all the money because she's not spending it on certificates anymore, so she spends everything on software now. And this means you can have a new license model that says, hey, contribute to open source. And this can be baked into a package manager that does it automatically for you. So if your software relies on open source work, you can create some rules for splitting your revenue and directly distributing for every sale to these packages that you're using. And they can, of course, do the same. And this is Ethereum flavored packages. It has a specification, it has a reference implementation. You can use it in the browser, you can use it in your Node.js application, it has CLI tools, and you will find everything relevant to this project on this GitHub page. And you can build a lot of cool stuff with it, like decentralized package managers, where it doesn't matter if it's on IPFS or Azure or AWS, you can always verify the origin. Even if it's something that you don't know, USB stick, you can still verify this is coming from the author that I expect it to come from. And you can build plugin systems, and you can build software like Ethereum Grid, and a lot of other cool things. That's it. Thanks for your attention. Okay, questions. Do we have time for questions?
Yes, we do.
Okay.
The last slide, the GitHub slide.
Yeah, exactly. That was my first question. But
This?
yeah, exactly. Great.
This.
No, the URL. Can you show the URL again?
Yeah.
I just wanted to
Yeah.
take a snapshot of that. But I also have another question. That is, like, if you use something like a GitHub URL or like a name, like a DNS name, as proof,
Yeah.
then what prevents like the malicious actor of like entering my GitHub name or using a domain name that looks very, very similar to my domain name?
Okay, so to get the question right, so you're saying I say I'm using my GitHub handle as my like name record for my key. Yes, you can do this, but the cool thing is what you can also do is you can have something like continuous certification services that are going. So you can, for example, you can create a self-signed certificate, a file that you sign with your key, and then you post it on GitHub, and then you can have services that are scanning the GitHub repo for these files, and then they could countersign your certificate, and then you kind of end up with the same thing that a certificate authority does, only with proofs by independent servers, something like Keybase, for example. They could see this proof that you did, and then countersign it. They would say, I checked it, and the file was there on the GitHub repository. This does not prevent, of course, that someone would hack your GitHub account and then change the certificate, for example. But the other thing is, it doesn't matter, because if they hack your GitHub account, they can also change your code, can upload new binaries. So then it's already like the worst case situation, kind of. If they have access to your code base and to your server and everything, it doesn't help that your certificate is safe.
A very, very cool project, definitely. I'm curious to see like the command line and that. So I was wondering like what's like built into what you have already. Like probably you didn't have time for a demo, but in terms of doing that, I could also imagine like you just want to ensure that the next version of the package is still signed by the same guy, something like this, right? Could be.
Exactly. This is a great thing. This was actually one of the ideas, because we saw the problem in NPM where the maintainer of a project changed, and the new maintainer was an attacker, and they uploaded malicious code. And then the original developer said, "Hey, I'm maintaining this module, and I'm not getting anything from it, and it's a lot of work, and I don't want to do it." So I gave this guy ownership, pretty much, which is a crazy situation and affected a lot of projects, and it was also targeted against crypto wallets. And the idea is, of course, if you have a key, for example, that can hold funds, you would not transfer your key to the new maintainer. And then you can have a package manager that automatically detects a change of ownership and does warn the user or says something like, hey, do you want to add this new maintainer to the list of trusted authors? And then at least you have an alert system that something changed. Because the current situation is that this completely goes unnoticed, and then you get hacked. Yeah.
Sorry, if you get back to the way that signing certificate work, I don't really understand why you oppose those things and you, as a result, get to the conclusion that I will be able to save some money, because I see this as complementary. What the code signing certificate, what they do, they actually give a call to that number. They make sure this business exists. If you use them,
yeah, you're right.
already.
So there are good and bad actors. So there are certificate authority that really do their due diligence, and they will check, okay, is it a legit organization? They will maybe do some background checks, whatnot. Then there are also like black sheeps that do just a call, or maybe not even a call. Maybe they prove nothing at all. Sometimes it's even the situation that these certificate authorities get hacked or that their keys leak, and then you have a really bad certificate authority that can sign every single certificate as like legit. This situation can also happen. And of course, yeah, it is a working solution, and I'm not saying it's completely useless, but I just think that it makes sense that if we have something like ENS, which is pretty cool, we can see it as an alternative and can see how far we come with it. If these kind of things make lives easier for developers and users, then I think it's a more viable solution.
So here, just to be clear, you've created a whole other layer of package management? So you
Yes,
have another pack, it's not a wrapper for existing package managers, or?
No.
No.
So
It's all new repositories?
Yes, so EthPackage it started pretty much just with the idea to, I have to go back a lot of slides, but to the idea to just place the hashes and the signature inside of the package. And then it abstracts, like you can use a zip file, it will place them in a secret directory, and then you have the verify and the sign function. This was like the first draft where it had only these two functionalities. So you could extend a package and make it a signed package, and then you could verify a package. And we realized for our own, during our own work on Grid, which is a binary manager, which is why I put the last slide here. So we were in this situation. So we wanted to offer a simple download for binaries from Geth, Parity, Besu, and we discovered they're all using different hosting solutions. So some are on Azure, some are on AWS, Bintray, and then we had to implement these backends. And we were running in the situation where we were challenged to make sure, like, if this is coming from like random origins, how can we make sure that in the end the package that we're using is still secure? And this brought us to package signing, and we had to implement a lot of functionality for this. And because it goes so well together, actually, that you abstract from the origin with your signatures, now everything got baked into EthPackage, and you can use it actually to fetch packages from all these locations. You can publish them, and in the end, it doesn't matter where they are. You can mirror them to IPFS. You can use a CDN. It doesn't really matter. And Google is actually working on something very similar for signed requests, because they want to use caching, and the browser kind of prevents this when the origin changes because of the content delivery network. So they are also exploring like signed packages for this, and it's just a great use case. And we put all the functionality into EthPackage now, and yeah, so it's a package manager kind of. It does not do dependency resolution and these kind of things.
Last question? No. Yes. Thank you.
Thank you for your time.